Okay. To understand how the graphs of hyperbolas work, a good place to start is a quick review of the graph of an ellipse because the graphs are very similar in terms of how you construct them. So this ellipse, um, if you don't understand what I'm doing, then you need to go back to review ellipse graphs. But the vertex, not the vertex, rather the center of this ellipse is going to be at the point 2, -3. So this will be the center of the ellipse. And we know that a equals 4. So we come out 4 to the right of the center and 4 to the left of the center. And b equals 3. So, and then you would just draw your little ellipse like something like that. And that's not bad for freehand. And so this would be the major axis of this ellipse. This would be the minor axis. These 2 points here will be the vertices, and these 2 points here will be the co-vertices. All right, now suppose I take this ellipse and change the equation by simply changing that plus to a minus. And that is the only difference between the equation of an ellipse and the equation of hyperbola. And so we have those same 4 points. We start with those same 4 points. And all we do is we create an imaginary rectangle from those 4 points. Let me try this again. And those same 4 points are the same. These are the vertices again, and these are the co-vertices. So we now have now the diagonals of this rectangle here are going to be the asymptotes. The asymptotes are simply the diagonals of that imaginary rectangle. The rectangle, of course, is not part of the graph, but it's diagonal. Neither are its diagonals, but the asymptotes play a part in the graph. And so you simply create that diagonal using your A and B values. A equals 4 and B equals 3. And and so since the x term is first, we know the horizontal points are the vertices. So this hyperbola would just look like this. And it approaches those asymptotes. And that's pretty good. So I'm going to just flip him over to the other side. Now, so this is the graph of this equation. I'll make that green, and I'll make the equation green. Oops. Now, suppose we change the equation by simply trading places with x term and the y term. Now, since the y term is first, all that means is that these 2 points become the vertices and the other 2 points become the co-vertices. So now the hyperbola is a vertical hyperbola, and it would approach the same. This asymptotes would be the same. That's pretty awful, but you get the idea. The asymptotes are the same, but it's got a vertical axis instead of a horizontal axis. The the variable that comes first determines whether the hyperbola is an up and down hyperbola or a left and right hyperbola. A and B don't change. A is still 9 for the hyperbola, and well, sorry, A and B do change because now here in the green, A equals 3, B equals 9. The blue, A equals, I've got that backwards, 3, B equals 4, and let me go back and fix that. That was craziness. A equals 4 and B equals 3. Because A is how far it is from the center to the vertex. Well, center to vertex, 4. The red hyperbola, center to vertex, is 3. Now, the foci the foci in for the hyperbola, for the ellipse, you've got the relationship that a squared equals b squared plus c squared because a is the largest of the three lengths. C squared, c would end up being the square root of 7 in this. So the square root of 7 is between almost 3. So the foci would be almost 3 to the left and right of the center of the ellipse. In the hyperbola, however, it's the other way around. We have a squared plus b squared equals c squared. So in this case, in both of them, we have a 3, 4, 5, so c would equal 5. So for the green hyperbola, the foci will be here and here, 5 left and right of the center. And for the red hyperbola, 5 above and below the center would be the foci, because 3 squared plus 4 squared would equal 5 squared in both of those cases. And the equations of the asymptotes, well, the slope of the asymptote is, well, depending on whether you're talking about the green or the red. In the green, um, this is B right here. This distance right there is B. And this distance right here is A for the green hyperbola. But for the red hyperbola, um, this distance is A, and this distance is B. So the slope of the asymptotes is either B over A or A over B, depending on whether it's an up-down hyperbola or a left-right hyperbola. And so you can use a point, you've got a point on the line, you can find the equations of those two asymptotes relatively easily. You just need to know their slopes, and their slopes are going to be either positive and negative B over A or positive and negative B. So the slopes of the green, the slopes would be positive or negative B over A. For the red hyperbola, the slopes would be positive or negative A over B. But it all boils down to that little rectangle there, whose diagonals the asymptotes pass through. And that hopefully explains how to graph a hyperbola and how to find the asymptotes.